Welcome to my new YouTube channel. This is Tanushree. I'm uploading the videos on the basis of the science stream, which includes the subjects like physics, chemistry, mathematics. I will take the topics from this subject and will make the video, and that will definitely helpful for you. So please do subscribe to my new YouTube channel and support me, and click on the bell button icon that will notify you for my upcoming videos. So please support me. So today I'm starting the video with the topic Bragg spectroscopy. In that, I'm going to explain about the Bragg's spectrometer, construction of that Bragg spectrometer, and the working of the Bragg spectrometer, and derivation of the Bragg's law with the statement of the Bragg's law. Okay, move on to that. Okay, this is the Bragg's spectrometer. William Henry Bragg designed for the first time the ionization spectrometer. He designed the X-ray tube in which the X-ray which is emitted from the X-ray tube and that is incident on the slits and falls through the slit and incident on the crystal C, which is confined under the crystal circular table T. The outermost layer of that circular table consisting of the vernier V that measures the glancing angle of the X-ray. Okay, this is the V, and the extended part of that circular table is the radial arm, which is consisting of the ionization chamber, which produces the ionization current in that chamber, and that chamber which is connected to the electrometer, which having the electric field, and that will measures the intensity of the ionization current which is produced in the ionization chamber. So this is what the ionization spectrometer that is designed by the Braggs in such a way that it will helpful to measure the structures and the molecules of this crystal. So next, the plot of the glancing angle and the ionization angle. So he plotted the graph ionization current with respect to the glancing angle. Theta 1, theta 2, theta 3 be the different glancing angles corresponding to them. The ionization current A1, A2, A3, consider like that. So this is the plot of the glancing angle and the ionization current. Next, we will move on to the construction. The X-ray from the X-ray tube are confined by the narrow slit S1 and S2 and are allowed to fall on the crystals, which is mounted on the circular table T that I told you, which can rotate about an vertical axis, and its position can be determined by the vernier V, the outermost layer of the circular table, which measures the position of that rotated incident beam with angle glancing angle. So that will be noted, and the table it is provided with the radial arm, that is extended part of that circular table, which carries the ionization chamber. In this arm it gonna be rotated about in the same axis of the crystal. Then the position of this arm can be determined by the second vernier. So second vernier which is present in the outermost layer of that radial arm. Okay, the ionization chamber is connected to the electrometer. It measures the ionization current. Hence, we can measure intensity beam of the X-ray. So the electrometer which measures the intensity of that X-ray. This is what the construction Bragg's designed. Next, working. At the beginning, the glancing angle, here theta, here Q refers to theta. So Q or theta which refers to the glancing angle. I have considered Q. So the glancing angle theta for an incident beam is kept very small, and the ionization chamber is adjusted to receive the reflected beam till the rate of the deflection is maximum. So at the beginning, the incident beam of a X-ray from the X-ray tube, which is incident on the crystal of a target, so forms a glancing angle which is a very small, and the ionization chamber which is present in the radial arm, the extended part of that circular table, adjusted in such a way that it receives the reflected beam from the crystal at the rate of the deflection which is maximum, and the glancing angle and the intensity of the reflected beam are measured. So glancing angle and intensity which is measured using the vernier scale which is present in that spectrometer. The glancing angle is not increased in equal steps by rotating the crystal table. In every rotation there will be a difference in the glancing angle. So the ionization current is noted for a different glancing angle, and the graph of the ionization current against the glancing angle is drawn. Here A1, A2, A3 which refers to the X-ray of the wavelength, and the glancing angle Q1, Q2 that is nothing but theta 1, theta 2, theta 3 corresponding to the peaks A1, A2, A3 are the obtained from the graphs. Okay, corresponding to the glancing angles, there will be a corresponding ionization wavelengths. So this is what the working of the spectrometer. Bragg's law statement: the diffracted X-ray interferes constructively when the path difference is an integral multiple of the wavelength of an X-ray. So the diffracted X-ray, which is constructively or destructively having the path difference, which is an integral multiple of the wavelength of the X-ray. This is the statement of the Bragg's law. Next, move on to the derivation of the Bragg's law. Okay, consider the above figure. Okay, beam in which the phase of the beam consigned when the incident angle is equal to the reflecting angle. Here, Bragg considered the three planes of the crystals, first, second, and the third, with the equal distance d and parallel to the each other. When the first ray, it is nothing but when the incident beam falls on the first plane, it's called as the first ray and reflected in the same angle. So the angle of incident, which is equal to the angle of reflection. In the same way, the second ray incident in a such angle in a such a way that the angle which is equal to the reflected angle. So this is what the figure. And the incident beam are parallel to each other until they reach the point. When they are at the point, they strike the surface and travel upwards. At the point B, the second beam scatters. Here, BD and BC is a distance traveled by the second beam. Okay, BD and BC are the distance traveled by the second beam. The extra distance, it is known as the integral multiple of the wavelength. It is nothing but the path difference. So path difference n lambda, which is given as BD plus BC. We also know that BD is equal to BC. They have the equidistance. Therefore, BD is equal to BC. N lambda is equal to 2BD. Here, replacing BC by BD or BD by BC. So BD is equal to D sin theta. Here AB is equal to BD. Sorry, BD is equal to AB sin theta. Angle is sin theta. Therefore, AB is nothing but the D. Therefore, BD is equal to D sin theta. Substituting the equation 2 in the 1, then n lambda is equal to 2D sin theta. This is the path difference. Hence, the diffraction X-ray interferes constructively when the path difference is an integral multiple of the wavelength of a X-ray. This is what the derivation of the Bragg's law. Okay, this video, I hope this video will helpful for you. So please do like, share and subscribe to my new YouTube channel and keep supporting me. Thank you.